Put that on. Assalamu alaikum everyone and good morning to all of you. Thank you for this session. Today we are going to talk about small language models. Uh, this would be requires some prerequisite, which I would be covering in a very brief, but objective is that you would understand. If any one of you is not, let's say, comfortable in full English, although I would keep it for all to mostly talk in English, but I'll mix use of Hindi and Urdu as well in between. You can put your question in the chat, and as per the time permits, I will take those questions. And at the end, we'll have maybe 15 minutes time reserved just for the Q&A part to it. Okay, what is my name is Irshad Chohan. I'm a solution architect, work at basically one of the cloud service provider named AWS, and I help customer right now mostly into the setting up their GenAI environment as well as the other solutions at large scale. So I wanted to basically share some of the learnings which I've done in past few months, and I wanted to share that. With this introduction, let me start. So this would be our agenda in very simple term that we are going to learn about what are these small language models, and how these are created, right? From a developer perspective, or if you want to have your own, or even if you are not going to create your own, how if you understand how it has been created, that will help you get the value from it or understand the value of it. So that is why we just wanted to understand their structure, their internal working at a level 1000, basically at a 10,000 feet up view. We are not going to go in depth of this conversation to keep it engaging with every audience who is at understanding this, but I'll give you some anecdotes how you can actually learn further deep dive onto any of these topics. And last, a very small demo on that how you can actually run these language models on locally on your laptop. Okay. With this, so let's understand what is, before we understand basically small language model, we need to understand what is an LLM or large language model. So there are many terms for people who are not in IT. They know it by the name of, let's say, Chat GPT or Gemini or maybe Meta in WhatsApp. Basically, this is where you are accessing a very large language model. Okay, what these models are capable of is generating text, right? Not only text, but there are different formats. Like you can generate even images and now videos and all. So, but in simple term, let me take it from a layman perspective. That what you do with a Chat GPT is actually a very large server hosted these very large models. So when we say large, this is like hosting across maybe at least 10 to 20 different machine to host one such model, right? 10 to 20 different server workstation or laptop, what you want to call them. So just to serve server, you want to do that, right? Now let's understand the technical part of it. So how this works is, in a very simple term, there is something called as deep learning is a field inside the machine learning capability. What it does basically, you can think this as a magic box where you provide all of your words, right? For example, here we are seeing input layer and certain hidden layer, and you get to predict an output layer. So for example, you can see each dot may be representing a word in a very simple term. Let's say today session is going to. So what should be the predicted word, right? So today's session is going to, it feed into this machine. So it does, let's say, some calculation, some combination, some calculation again, some calculation again, and eventually predict, let's say the next word would be conduct, right? Or next word would be present, right? So today's session is going to conduct, or today's session is going to present. That could be my next predicted token. So that's how it works. So for example, not only one word, and now we get this one word, we'll add it again. So today's session is going to conduct, maybe the next word would be on. Then today's session is going to conduct on small, then language, then model. So this is how it actually predict the next word. So in a very simple term, you can think about this. I will feed in some of the text inputs to this particular model, and basically these large language models which takes billions of parameters, so you can actually pass a very good amount of data and it runs across this multiple parameters, which we'll discuss what is parameter internally, and eventually you predict the next word, right? Let's we only talk about, let's say, text today, just to keep our discussion short. So basically, you are predicting the next word. So once you have a large model, it has more intelligence, more basically combination, which gives you more realistic data, right? So that's how it is done. In this example, we are just showing, let's say, this just the five input parameter and one output parameter with only two hidden layer. But in typical world, these layers could be more than 20, more than 30, or even more than 70 in different cases. And plus, this input layer is also in thousands, if not thousands and 10,000s as an input layer, and it can be even more. So, for example, some of the large models right now. So, if you say, they will ask you, they will tell you something about context window. So context window is actually, you can say, is a length of input. So some say कि 200,000. That means it can take 200 thousand is 2 lakh words token into as an input, right? Some has 128,000 context window. So there could be 128,000 such words which you can ingest into this. Now, so this is what we call, but again, now the next thing is, each of these dots which we represent, computer only understand ones and zeros, and on a higher level, it could be only numbers, right? So every text which what we speak, right, it we need to convert that into numbers. So there is a concept called as vector embedding, which we are not going to discuss today, but it's like a very simple term. Maybe you have all these word, and every word you have some representation in terms of numbers, right? So every such block represent a particular number, and only so input is something which you control, and output is what you get. And what we do, basically, we train this model in such a way that every time we pass, and if something goes wrong, if word is not correct, it will tune these hidden layers, basically. So we'll say कि the number value will change. Let's say hypothetically it was 1000, we'll make it 1 2 point, every value will be between 0 to 1. So it could be 0.198, 0.78, 0.66, something this. If we predict right, we'll keep it more. If we predict less, it will change those number. So after multiple such iteration, that's how the training works actually, right? So each of this number at every node, right, is starting from the input layer, and at these hidden layer, and there are certain other layer which we use internally. All these numbers store in a single file, and that is what we call as a weight of the model. So if you see, weight is nothing but a matrix of this model. Okay, so it's like every okay, hidden layer 1, first value is 0.98 comma this comma this comma this, second is 0.66 comma this comma this comma this, that, right? So all these is stored in a file. So that is what we call the weight. So after training this model, after, let's say, maybe for a days or a month, depends on the size of model, and you get these tuned weights, basically. So basically you think about these as a knobs switch, which tune it to get the right results, basically. Okay. Now, what is the parameter? So, for example, that's typically we call key. Let's say GPT is 200 billion parameter model, or Meta Llama is 405 billion parameter model, or Falana model is a 7 billion parameter model. So, yeah, that is basically, you can simply think about this, that counting these these dots is nothing but the parameters. So every 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe here 5 plus maybe 15 plus 1, 16 is the parameter for this particular representation. So you think about this. So today's world, even the small language parameter models are at least in billion, maybe 1 billion, 3 billion, 7 billion, 8 billion, that way. So the large language model, which we typically see right now or work with, is 200 billion and above model typically, right? So let's understand these three things. So everything basically as a text converts into a number using vector embedding. You can learn later on this. Now weight is the floating point value, or basically a number value for each of these input points, and all these points combined together called as a parameter. Okay. I'm just simplifying it for there are certain nuances in between, but that's how it is to understand. So this is a 16 parameter model with maybe a weights posted on all each pointers, where input length is 5. Okay. So so how large are they? Right. So for example, we said GPT-2, when it released in 2019, it was 1.5 billion model. GPT-3 when it released, it was a 175 billion model 4 years back. Now 530 billion parameter GPT-4, which is estimated to be 1.4 trillion parameter model, right? So challenge, and this is how it is basically. This is a more representation of the same. That yeah, these are three input pointers, four two hidden layers, and maybe two output layers on this. This is how it is basically designed. Now, challenge is that running across such a large system, you think about this, ki there are 2 lakh input layer and maybe a 30 layer such between, and then there will be an output layer which runs across 530 billion or a 600 billion or 405 billion parameters internally, calculating one word. Oh, sorry, calculating one token, or basically in our discussion, one word will run across this, right? So it would run across this and predict just next one word. So if I'm predicting, let's say, a simple 10 words or 20 words, it would run this across 20 times, right? And that is what it actually becomes very basically very computationally expensive. So basically you requires multiple GPUs. Maybe hosting 1.4 trillion parameter model would requires maybe a server in numbers of 100, right? So that's how it is. So that's what. So now to understand, for example, how much each parameter, let's say 1.5 billion parameter model, requires how much memory. So that's what we need to understand. So it's like number of parameter multiplied by their precision. That's the size. So precision is again, precision is what we call is how accurately you are storing this number. Okay. So if we are storing, let's say, because since I said it's a number between 0 to 1, it could be a decimal precision up to 16 digit, or decimal precision up to 32 digit or more, right? Accordingly, you set this. So here, if you store, let's say, something in a floating point 32 bit representation, that's a full precision, what we call float 32 or FP32. That requires 4 byte to store one parameter, right? So it's like very simple. If it is a 175 billion parameter, multiply this by 4 byte and then divide it to make it in GB, that you will get the number, right? So for example, 1 billion parameter into 4 byte is like maybe 6 billion bytes. If you convert that into GBs, it would comes to around maybe 5 to 6 GB memory, right? So that's how it is. Similarly, if you want, what I can do, I don't need, let's say, full 32-bit precision. I reduce it by half. Still, it is a 0 point something numbers, but it is stored up to 16 digits. So maybe I just need 2 bytes. That would reduce same storing of this 1.5 billion model. Maybe just requires a 3 GB of memory, right? If I go by 1 byte, I maybe require just a 1.5 GB of memory. Okay. And if I'm storing even integer on a half, right, int 4 which you call, that would reduce the number maybe just by 4 bit. So it would be just 0.75 MB memory. Okay, sorry, 0.75 GB of memory basically. So so you need a precision and you need a parameter. So basically these are the parameter which you can tune and control while setting up these models. So just to give you this idea, 8 billion requires a 16 GB model storage, while floating point 8 representation will require a 8 to 8, because it is storing floating point in just an 8 value, while a 4-bit representation will be half. Similarly, 70 GB would be this that way. This is like some of the model which you can store. Okay, so we covered basically the parameters, the weights, and how to calculate the memory. Okay. So this we were basically till now discussing how we basically create these large language model, or we call them foundation model. So maybe GPT-4, when it created with that 1.4 trillion parameters and model, right? And they created it. But running just one word, even on the, let's say, latest CPU or latest GPU machines, would at least take seconds to predict just one word, right? So if you basically wants to predict, let's say, full paragraph, maybe 100 words, that would basically take 100 seconds. So hosting such model for, let's say, chatting application or for such other application which requires a much faster performance is needed. So what we do basically, we create one foundation model, and then we create a smaller model out of that optimized foundation model, right? So these found is optimized foundation model can be of less parameter, but let's say holds the same level of knowledge and accuracy and the response type, right? So that's what we basically intended here. So if you go to Llama's website, or basically Facebook's company is Meta. So Meta also released Meta Llama models. So they created one foundation model with 405 billion parameters, and then from that they created a smaller language model, which was 70 billion model, 8 billion model, or even 3 billion model, and even 1 billion model, 1 billion parameter model, right? So yeah, so what it does basically, from a large language model, to get the similar kind of accuracy, similar, not same, accuracy and a special performance, you create the smaller model, which can be, let's say, if it is just a chat, right? So I can create, maybe instead of again GPT-4 1.4 trillion model, we'll create a smaller model, and that's what you see in GPT as well. They have GPT-4o, GPT-4o mini, right? So which is like a smaller model of the same, right? So that gives you much faster performance, and if you are using them in your application, maybe a very less cost. So maybe running the GPT-4o would cost you, let's say, X, then it would be at least X by 4 or X by 5 in terms of the pricing. uh, I'll take this question. I think this would come in the further slide from Abdul Samad. So once I reach there, I'll tell you. So how we do it? So basically, creating a smaller language model, there is a concept called as there will be a large language model which acts as a teacher, and we do a knowledge distillation here, or that's a process is being called. Using that, I will take the knowledge from the main teacher model, right, and I will teach it to the student model. There are different techniques. We'll simply refer it in the next slide. And a student model, whatever this student comes as an output, you simply think about this. Teacher first gives the data, and a student absorbs it, right? And after that, a student will ask a question, and then sorry, teacher will ask a question, and student would respond back, and a student's response will be then compared against the teacher's response, and whatever the difference is, student model tune it itself, right? So that's how it is. So for example, in the representation here, you are seeing that there is like two input window and two output, and there are three layer, right? And we here we are showing like 5 plus 4 plus 3 as an input, but here only one layer. So it's like in your small language model, you can reduce the number of layer, or reduce the number of height, basically you can say, for the hidden layers. You can do those to reduce the size. So what it does basically, but again, since teacher model is already gives you better responses, I use that to tune my smaller parameters now and still get a proper result. So that's what it does basically. Now, so to build it, we do multiple things. But again, now I'll take the question that how much will it affect the accuracy of the model if precision is reduced by 2 times? So, so precision is actually, so it depends on what types of how you are reducing it. There are different ways to reduce it. In small language model, or basically to reduce the precision, there is a concept called as quantization. Quantization is nothing but there are one is simple as we said, you simply reduce it by half and then test it. Typically, you still retain 70 to 80%. I'll say on a generic term that 70 to 80% accuracy is still maintained. But while as part of your training process, you tune that model so that that accuracy is still get up to, let's say, the 90% of the main base model, right? So mostly it drops based on the number of parameters as well, but that also you basically consider as part of your training phase, that how your student model can be considered here. I'll back and forth on this slide to start with how. So if, let's say, if you want to build your own small language model and you have a very high language model, here I'll take example again of Meta. So Meta has this four model, let's say 405 is my foundation model, right, which requires an 810 GB of CPU, sorry, 810 GB of GPU memory. So what I'm going to do, I'm going to create a 70 billion model out of it. So what I'll do, I'll create one teacher model of 405 billion parameters. I create a smaller model. I'll reduce the number. How can I do this? I again said the number of parameters are these hidden layers and the input and output layer. So maybe the teacher model has, let's say the input length of maybe 200K, right? And I can pass 2 lakh words into it. But I can do, okay, for my smaller model, I'm okay to have maybe just 32,000 words as an input. So what I'm doing, I'm reducing that half. Hidden layer, if length was, let's say, since input was 200K, maybe my each layer is of 400K, right? So I can have this like 4 lakh list of in single layer. I maybe say, okay, now I have just 32, maybe I'll have each layer of just 64. So there would be 64,000 list or basically vector arrays in each point. So, and maybe here there were layers of, let's say 60 layers, 70 layers. I maybe reduce that to 30. So these are the decision what you take to reduce the number of parameters. Again, the experts, basically the data scientists here who create these model, if they decides or basically they tune it, so that checking how much is the accuracy, what are the different layers, and how much each layer has to be keeping as a parameter by reducing it. So maybe they will say, okay, the context window will still be 200K, but my hidden layer will get reduced. So that's something which you decide and design basically. Another way to reduce the size is precision. So as it has been asked, ki maybe the teacher model was with floating point 32-bit precision. But what I'll do, here I would reduce maybe just FP8. Okay. So basically I'll say ki maybe the same size, hypothetically, same size of teacher model, but by half. So that's another way of doing it, right? So you do that. Or you can say I'm reducing the parameter plus I'm also reducing the precision. So that's another way to reduce the size. Then there are different techniques internally. We'll discuss quantization in the further slide, which will tell you that how you can think about it. The third is the compression, which is more on the storage part, since the memory utilization also being part of how these basically floating point words being stored in a file, right? So that also basically comprises here, and that's what also you need to think about. Just one more thing before we move further. Quantization or precision is also dynamic. We don't, one way is you do a very simple quantization where we say every parameter is by half. So every floating point value, whether it was 32-bit, I reduce it by 16-bit, right? Another mechanism is these hidden input layer, or there are certain like bench, you can say milestone layer or certain things which are more important. So what you do for those important layer, let's say input context window or the first two layers, like those positional, basically some special layers, for those I will keep the higher precision, but the maybe in the middle layer I will reduce the reduce the precision. So that also called as a dynamic quantization, where you say, okay, certain parameters I will reduce it, certain I will not. So maybe you will not get half the size, but maybe 60% or 70% of the size. But in that case, your accuracy of model is, let's say, instead of touching 70, we would start touching 90. So that's another thing which we consider as part of the algorithm. So, so now to reduce the size, three things. You reduce the number of parameter, basically reducing the height of the hidden layer, reducing the number of hidden layers, and as well as the reducing the input layer. Precision is where you reduce the data store for each parameter. And compression is the storage part of it, which comes as the rest of the three, but I'll skip it for now. Now, so this is like how you think about it. Once you thought, okay, okay, this is how my small language model will be. Now you start the training part. Now, so this for training, the you do training for three different things. Simple one is the response based. In this case, you ask the same question to teacher model. You ask the same question to student model. Okay, whatever the teacher model says as a response, and student model, let's say, says something else, you send the feedback to the student model. See, teacher ne ye bola hai, या teacher said this, right? You should tune your numbers in such a way that you should match to what teacher says. That's a response based distillation. Okay. Hope this is you got it, right? So that's the simplest way. Requires very less compute, and you can do that. So maybe to run that 8 billion model, you just need maybe one machine can run for 2 3 days and your distillation is done, right? So that's an easy one. Second is feature based. Feature is nothing but what I call it again. Sorry, I think it's got, hmm. Feature is nothing but okay. Feature is nothing but basically the value or stored at each parameter level. So that's called features or weights, is combining together all things into a single file called weight. So that's my feature. So if I want to match it, कि okay, exactly a teacher, what was the value at these typical nodes? I want to match those node internally, right? So this gives you better knowledge representation basically instead of a high level feedback, because what happens is, let's say you taught it on just request and response, maybe my parameter will be altogether different, right? And what happens is, on a new text which arrives totally new, my response may not be so accurate, right? But if I match it internal structure as well to certain level, that will give you more accuracy. So that's because that's we get up to the featured level. Now you go more in depth, you also maintain the relationship with the previous input layer and the next hidden layer. That also is a relation based level that requires more and more advanced computing capability. Or basically, if this requires, let's say, x resource, this would be x by 2, and this would, so x multiplied by 2, and this would be 3 times of that resource or utilization. So this you can do, let's say, hypothetically on 100 GB GPU machine. This requires you to have two such machines. This requires you to have four such machines to have this knowledge distillation. So many a time we do just a response based. If it is, let's say, a use case where you wants to create a knowledge distillation for a specific domain, but if you also wants to understand a particular critical reasoning and thinking of the model, there you also want to do go deep dive for a feature based and relationship based. Now so this is the, like, this is the size how you reduce it, this is how you basically train it. Now how you set up this infra. So for training this small model, there are three techniques. One is offline, online, and self. Offline is where you already have a ready 405 billion model, right? Maybe basically any such large model, you already have it ready, and you attach it to your main model, you smaller language model, and you train it. That's called offline model, where basically the large language model is ready. Online model is where you basically attach it to the your online model is also being trained at the same time. So you pass the same data. The large language model is also being trained at the same time, and the same time you train your smaller language model as well, right? Because let's say Llama, next time if they are going to release, they would they will train maybe a 400 billion model as well as 7 and 8 in the same pipeline, because I'll pass the same input to all these models. Whatever the response I get from the top, I also pass it to the below one, and I'll tune it accordingly. So that's called online distillation. Typical for us as a data scientist or most of the company who are not building the large language model does not opt for online, they only go for offline models. Self is again, it's like combination of online only, where you also tune it effectively. It's more complex, I'll skip it for this discussion. Now these are some of the advantage, and this is where I'll take questions from anyone if it is. It will be interesting to see the training demo on knowledge distillation. Uh, the demo may not be today, but maybe what I'll do, I'll pass a reference link, uh, maybe a YouTube link, which allows you to see this process, because that would take again maybe the full session. Maybe in future we can do that later. How training occurs in feature based and relationship based training methodologies can still be same, either it could be online and offline or the self model, any of that training style can be done. So it's only that instead of you tuning just based on the response, you train based on the internal feature representation. And since if you get up to the feature level, basically you are changing the whole matrices of matrices internally of hidden layer every time, or you basically you are computing that every time. So that takes a more computing power. And same relies to relation, because that's like one more added layer. Okay, what was the back layer, what was the propagating layer. That's what it takes. Hope that answered the question. Now, why we do it? Again, training efficiency. That instead of training a very large model, I can still train the smaller model and still get the better output. Just to cite you an example, DeepSeek R1 has released, right? I think most of you might have heard at least the name of DeepSeek. So DeepSeek created a 671 billion parameter model, right, which is gives a full thinking reasoning capability, but 90% of that thinking can be distilled into a 70 billion model llama 70 billion llama model. So what they did, basically they created this DeepSeek R1 reasoning model. Using this offline mechanism of training, they trained a smaller llama 70 billion model for mathematical and for special categories, and they get to the good quality. And that's the another thing which comes to small language model, that I'll jump to the fourth point, that it can be very good at a specific task with better accuracy and speed, and sometimes matching or even let's say going more than the large language model as well, right? So that's again basically what it goes for. And third thing, what the benefit here is, it can be deployed to smaller machine. Let's say hosting DeepSeek R1 would require you to, let's say, at least $8,000 a month billing, right? Whereas the same 70 billion llama maybe just can be done within $1,000. I'm just giving you hypothetical numbers, but that's how it is. So since that's like just a 70 billion instead of a 671 billion parameter, so the amount of storage and requirement is all less. Second, it is speed becomes very fast, right? So and that's why it becomes also cheaper. If for many of our use cases, let's say simple summarization, simple text extraction, or mathematical solving capability of class 10 and below, uh, that is all matching at even at a 70 billion model capability as well. So if I can get a matching capability, let's say for my requirement, if I can run on a smaller machine, the cost of my service is also low. Second, if it's just a simple text-based response chatting, right? It has to be faster. I can't run it on a 670 billion and wait for 3 seconds every time, right? I would run it on a smaller one and get maybe 200 token, or basically 200 word being presented every second. So that becomes very quick speed actually. So in those cases, uh, a small language model being preferred a lot. One more thing is something called as agentic approach, right? So this agentic approach basically in generative AI, or basically today, is very much tuned in such case that instead of relying on a single knowledge of a very large model, I'll design a process, and that process will take a small model which each are expert on a specific task, right? Maybe fine tuned, maybe or maybe a knowledge distilled model, and I use them to do my task. So this becomes very computationally cheaper, and as well as gives me much better results. So that is why the future of generative AI is going with multi-agent and small language models actually. Another question from Umar is, can you talk about more on the GPU infra required to train, let's say, a 7 billion parameter model in FP16? 14 GB is just to store the weight. Good point. Then we have to store activation, correct? So that would you recommend how much slack should be there to keep it? So there are three things actually. There is a KV cache value, there is weights of the model, and the activation function. All these three together just for the inference. Multiply that by at least 4 to have a training model of that. So in simple word, if you're this is requiring a 14 GB model, maybe you think about at least 64 GB model GPU would be required to train that, infer it basically, or basically training it from scratch. Now, knowledge distillation can still be less, or maybe fine tuning. There are three concepts actually. Maybe I'll just digress a little bit. Training the model happens in three different ways. One is pre-training. Pre-training में आप क्या करते हो? What you do basically, you simply pass text, right? So let it make the some assumption out of it. I'll simply pass the whole book, the entire internet. That's called the pre-training phase. From you simply have a model. Let's say everything is 000 or random, any random value. I'll pass the text, and then it will automatically sets it up. I'm not asking it to predict anything. That's the level one. You do pre-training. Once you're done with the pre-training, then you do fine tuning. Fine tuning may you pass your question and response. Let's say you pass, this is my input and this should be the output. You pass both of, basically you set the input and you say output should match this. So it run it through, and if it does not matches with the output, it retune the parameters internally. That's called the fine tuning. Now especially any even large model or this smaller model as well, we always not create this full student model. We simply do just a final layer fine tuning. Maybe I'll not change all the 30 layers. I'll maybe just add one more layer at the end. I'll have Q&A pair, basically question and answer, or request and response. I'll pass them together, and what it using that data, it will tune my final layer one more. That will give me a fine-tuned model for my use case. That is much cheaper. Maybe even again 14 GB model can be done on a 32 GB GPU machine as well, and fine-tuning can be taken care in that case. Right? Knowledge distillation is kind of a mix of both. If it is response-based distillation, it can be still work in fine-tuning type of a style. But if it is reasoning and others, it takes that another layers also into consideration, so requires multiply by 4 of GPU. So in simple term, for pre-training and knowledge distillation, would requires at least model training requires at least 4 times of the weights, billion parameters. Sorry, weights of the model. Whereas if it is just a fine tuning, it could be multiples of 2. Hope that answer your question. The another question, I think my question is basically for distributor training, if model doesn't fit in a single GPU, which tech stack training framework would you recommend? Okay, so I work in AWS. So we have as I'll talk. Maybe I would only know about that. So we have a concept called as hypercluster. So even though that also helps you basically set it up where you can share model weights across multiple nodes. There are different internals which goes like if your activation, how big is your activation, based on that you define your GPU size and accordingly you distribute it. Eventually, if your memory bandwidth are being shared across multiple machine in the same cluster, where basically multiple computers in the same node, if they have very good in network bandwidth, uh, at least more than gbps, not 1 gbps, it should be more than that. Then you can think about scaling it across multiple machines. Accordingly you can set it up. Again, answering this question requires how big model you are training this. If it is just a 7 billion, 8 billion, you can still have a 1 Gbps connectivity between two GPU, and it still can take care of it. But if you are doing that on a cloud, then most of the cloud provider, including AWS, gives you those capability out of the box that internal network bandwidth will be very high. So that allows you to share it. The framework we prepare preferably from AWS part, what I know of, we use SageMaker Hyper Cluster and Inferentia Hyper Cluster. Both allows you to basically set that up. I may not know the open source part as of now, because that's I've not been familiar or tried those things right now. If other experts are in the group, maybe they can help you answer that question. Shakir Hussain has a question that how agentic AI work. So agentic AI in a simple word is more like a process. So for example, if you're being hired in a company, right? Maybe as a developer, right? One thing is you simply being shared let's say requirement from the customer, and you say you build it. You are a single person company. You do capturing requirement. You write the document. You think about it. You design the code. You deploy it and done it, right? But if it is a large project and is especially in company, we have a role separate. What we do, okay, who talks to the customer is a business analyst who understands the domain, who understands the nuances of customers. They will create in a more functional requirement documents, and they will then share with the architect. Then architect will think about how would you design it. And then architect pass it, okay, this seems to be a job of a front end engineer, this is a back end engineer, and this is how want you to deploy it. Architect does that. Then these front end engineer, back end engineer, and let's say infra guy, DevOps is working together to build this. They deployed it. Then there is a tester comes who test it, and then we release it. So it's like front end, back end, DevOps, architect, uh, business analyst, and the tester. These are the different roles each is playing. So instead of asking okay, one pass and do it, you set this as a process, and each layer is basically being talked to talk in such a way that, hey, imagine you are a front end engineer, and this is a special knowledge what you have, and you are specifically done for this particular task, and then you do this task, right? And the another guy is doing that, and a third guy is doing that, and everyone has a very specific role in it, right? It could be a different specially tuned model. Let's say if it is something related to coding, you do, let's say, connect to Claude, Anthropic Claude, which is very good in coding. If something is more in the summarization, maybe a very small model of Llama can also do. If it is just a business analyst job of thinking, they maybe you will do a simple Llama 70 billion model itself, right? So that's how you differentiate between these tasks, and one guy who will be consolidating between each, one guy who's simply testing it, validating things out and all. Role is separated. That's how you design, call each generative AI to think about it, and that's how you design. So that's approach which is being done a lot, and that's how it is being considered. To start with, which DL framework we can start with? Uh, Sorry, I have not got the question. If you can elaborate, we'll take this question later. So again, let's move from here. So again, just to reiterate, training efficiency, faster, cheaper model can be deployed in a smaller edge machines. I think next task would be to deploy these on mobile phones. Special mobile phones are still, uh, if your mobile has a good 16 GB memory and all, there are very small models which can still be deployed on mobile phones as well. But I think in future that would be more useful, and it can be done for a specific task. If you see DeepSeek, before even releasing reasoning model, they were basically very good released DeepSeek coder model. They means a smaller model with a very good coding accuracy. So that's what you can do. So if you have a special language or a special coding style and pattern, even those can be tuned here basically. Okay, so we understood this. Let's touch base on the quantization and compression a bit more. So, quantized, what is quantized? Let's understand that. So, for example, let's look at the below picture, high precision picture. One single digit is called 1.3. Vector is, let's say, value in a single line. It could be not just two, maybe hundreds or there. Okay, so it is 1.4, 2.7. Matrix is called where you have 2 by 2, 3 by 3, 4 by 4 grid, right? So it's like the matrix is like this. Matrix of matrix is called tensor. So here what we are doing, we are storing everything with, let's say, one bit precision, sorry, one digit precision in simple human words, right? One digit precision, so 1.3. But let's say to store it in quantized format, I'm simply compressing it, stripping it out, and simply storing one. It 1.4 and 2.7 being stored as 1 and 2, 1, 3, 2, 4, something like this. You can have more dynamic, maybe you are doing rounding off instead of this, maybe you will have a different accuracy. You say one tensor I will keep it float, one tensor I'll not. That's called dynamic quantization. Those are different techniques, but eventually idea is this, right? So for example, I think this we have discussed. Again, like, you know, to compress the size, this is what you can do. Compression is also based on how you store it, so that we would be covering in the subsequent slides. Okay, so let's look at the demo. So there are different ways how you can run this model locally, even for any new developers. If you have not done it, there are different sites. I'm just saying some of the example which I have tried. Olama is very much and very easy to even start with. So so I'll show you. This is a site. Let's say if you go to olama.com, right? You can search. It hosts its own lot of model. So if I go to DeepSeek R1, so they host 1.5 billion parameters, 7 billion, 8 billion, 14 billion. All models are there, right? So if you go click here, model, you also see. Sorry, let me show you. So it talks about what types of quantization they are using here, right? So it says architecture is Quen2. Quen2 is like what is the base model on which these are distillation model, most of it, right? So architecture is basically it's a Quen2 model which they trained or distilled from the DeepSeek R1. Parameter size is here 7.62 billion in specific numbers, and quantization here is Q4 km. Q4 km is one of the technique. 4 is like you can simply think about the 4-bit storage. Okay, rest all is like how much which style basically it is using and all. Now if you go internally, you can go get into more details like which version, size, label, sorry, these are different, how many blocks it has, right? So for example, I said There are multiple blocks, and each blocks has its own biases, weights and all. So you can say there are like say 28 blocks of layers which runs in this 28 hidden layer in high level words, right? Each bias is a 512 vector, basically 512 value being stored in floating point 32 bit to store the bias, but weight has been stored in is a matrix, but that's a quantized one. A normalized weight is stored in this, output weight is stored in this. For each layer they have configured in this way, right? So this is a dynamic quantization scheme which uses Q4K format, and it stores like biases are stored at the weight, whereas other weights has been dropped to just a 4 bit. So that's the quantized technique actually which has been used to design this 7 billion. You can check for 1.58 billion, 14 billions and all to get more information. Okay. Llama models, this is very much state of the art from the Meta, right? 70 billion model, and 3.3 has 70 billion as of now, but I think 3.2 has 8 billion, 1 billion models as well. And see, it also talks about the accuracy in terms of it. So, for example, what it says, Llama 3.170 billion versus the now, it has more or less same. This is Amazon ka Nova Pro, this is Gemini Pro, and it matches up to certain accuracy in benchmark. This is the benchmark actually. Somebody tested it on, let's say, certain specific input and output, and it gives you. So if something is very good in code math, let's say Llama 3.3 is good in mathematics, zero shot, right? But reasoning mate is not equally good, maybe just 50%. Okay. But if it is language wise, it is quite good, 91%, right? So if you are looking for simple language translation to, let's say, top 10 to top 20 language, then this model can be considered on it. Like if it is a simple instruction, whether it follows correctly or not, this model is good. But if you think, go back to DeepSeek is not so good in the reasoning capability if they have added the benchmark. Sorry, instruction following. But output and all, it gives you quite good, right? So that's how it is. So you can check the benchmark, how good is the accuracy and all. Phi is from Microsoft. So if you go for Phi, they have released their model, and they are also saying how much accurate they are actually going it. Think about this, last year, let's say GPT-4o, where was a very heavy 400 plus billion model, giving a 77% accuracy, 77.9, sorry. But 5.4 now with just 14 billion parameter is surpassing that accuracy. So that's how things are basically being changed. 3 years back, what GPT-4o was doing, within 2 years, we are able to achieve that with much less in the output. So basically, that is what is happening with generative AI. That it's not just increasing what we say, let's say every year doubling the capacity, maybe every year 4 to 6 times of the capacity. One time CPU and GPU tuning, more new model architectures are coming. On the other side, the model itself are becoming so much better in the capability, surpassing the previous one. Okay, this is Llama 3.2. Yeah, okay. So this is a good site which you can basically starts with. And let's say you want to deploy this model, right? You need to understand the parameters, how it actually talk. So these are the sequence, uh, and the template that if you need to pass, this is how you should set your knowledge. Okay. This is how you basically calling it, but don't worry on this. There is a very simple format to do this, and there is a license that whether you can use it locally or not. You just need to run this one command, olama run llama 3.2. Okay. So I'll show you a demo. So for example, this is, I have installed the olama on my local machine on the terminal. These are different words. If I have to create this on API, I will say olama serve and the model name, right? And it will start serving that model, right? But if I have to just let's say run, I've already downloaded DeepSeek on locally. Say Olama run DeepSeek R1 with 1.5 billion parameter, and I'm asking this. Explain the basics of machine learning for a 6-year-old with a real world example of pet training in 100 words. And I pass it, and it runs locally on my machine, and it is giving this kind of an output, right? Since it's a reasoning model, it was typically uses thinking block to think it, and then your output is after that thinking block. So machine learning is teaching your pet to roll over and in circle using treats. It lets computer learn this, blah blah blah. That way you can say. Maybe if I'll say in Hindi, let's see if it. I have not tested it. So maybe, yeah. See, Hindi is not good. At least I'm not able to read it. So, it, mm, maybe I'll say Urdu. Urdu, so I think it would be pretty bad. Maybe I'll try Arabic. So if you see, most of the time thinking block is all in English. So that's one part. So again, I don't know whether it is good or bad, but this is how the output is. So since even a very small 1.5 billion parameter model is able to generate these tasks, right? So if I remove these things and maybe ask the same question, ki, so maybe the same question of SLM, and then it will tell you about what is it. And sometimes since these are small model, they are not able to get you to the right answer, and in some it goes out of the block as well. So here it so we ask the knowledge distillation. It talks about teacher and student model. It talks about what teacher model, what it does, output utilization, temperature scaling, entropy based approach, blah blah blah. Certain things more complicated, but if I'll say okay, okay. So it will then again think about it and generate. So this becomes very easy way to run this model locally. Another mechanism of running this is using llama.cpp. So llama.cpp is an open source project by ggml, right? So llama.cpp is allow you to host this on multiple machines. The good part is even if your machine does not have a, let's say, a GPU, right? GPU, no GPU memory, still you can run it because it has a integrated automated conversion that even the GPU model will convert and run it on CPU machines as well. If you have CPU and little bit of GPU, it can do that hybrid as well. Somebody was asking to run it across multiple machine, it can do that as well. Okay. Apple Silicon Mac, if somebody is using Apple ARM based machines, that also it will take it. It supports some of these model, especially what I've not tried Llama, but VLLM. It allows you runtime quantization actually. So for example, you say, "Okay, this is my main model, and but I wanted to run it INT4." It will do that runtime. Of course, it will be a simple quantization, which will make every parameter into an INT4, and it will take care of it that way, right? So that's how it is basically do that. So these all models are being supported and tested on this. Lava is a image generation model as well. These are the libraries available in each of these packages which you can use. There is tool, some I think CLI would also be there in this. But what I do for CLI testing, I use Olama, but and inference I typically use VLLM actually. For if I have to do run it on machine, because it by default support both Intel, AMD, even Amazon Trainium machines and all, AWS Trainium and all. So and it provides a lot of other options as well. Okay, so if you want to test these model out, maybe even if you have 16 GB memory, try maybe a 3 billion model to start with and see if it works. If you want 16 billion model, right on 16, maybe check yourself whether 16 G, maybe 16 GB, 16 billion parameter model quantized with 4 bit, which gives you 8 GB memory, is better with respect to 8 billion model running on a one maybe a floating point 16 or floating point 8 representation, which are again basically using the same memory but different size. So that's what you basically take a best guess whether 3 billion parameter on a full precision, which is again 8 billion, 8 GB memory, or 8 billion parameter on 1 byte precision, or 16 billion parameter model running on a half byte precision. Eventually, all three use the same memory, but whether each which one gives you better performance. So that's a call between which you can take up and run this across on your machine. to test them out. These are some of the references. I would suggest if you want, you can take a screenshot of this, go through these link. Maybe I can copy this, uh, and here I'll take other questions as well. Maybe I'll share this in the chat as well for others to copy easily. So hopefully, I was about to talk about. I'll take some questions which are left. Do we need model architect like Distilbert? Uh, you may not, but yeah, typically for knowledge distillation, there are many various architecture which you can follow. Distilbert, I don't know which particular type of distillation architecture this follows, but yeah, this is easy. TensorFlow, yes, I think that Hugging Face is, I think, more popular right now in terms of the architecture and the storage of these models. Most of these models are available on Hugging Face, even the DeepSeek and all. So it's better to create a simple ID on that and start downloading directly from it. For me, I think exploring more a VLLM model for inference perspective first is becomes much easier for the developers or for people who are relatively new into this field. They can simply utilize it. Can you please talk more on the GPU infra requirement? Let's say it's 7 billion parameter in FA16 14 GB stored, then we have to store activation. So what would, and how much slack would you keep it? I think, sorry, this I've asked. Is there a way to run it on your machine? I think I've answered this. Olama is a good way to go. Llama.cpp is another one. If you're simply developing an application locally, it's better to use VLLM llama.cpp or use olama.serve basically, right? Again, you can go to the Olama sites. I've shared the link, and that will give you how you can actually uh, serve through API or use a model which run that as a containers to serve as an API. Both is there. And I think somebody has already given a good points. Yes, free code camp. How to run open source model using Olama? Good. It could be any model, Lava model or non-Lava model. That's about it. I'll share that YouTube link later. I don't have that handy, but yeah, I will pass that. Uh, Medium architecture, Moria Anup. I think maybe it's just okay. Sorry, this link I have shared actually. Okay, so please copy all these links. These are all different links actually, which you can run it, and hopefully this session was helpful. Any other questions from anyone? We'll take it. I'll be there for next 5 to 10 minutes based on the questions. For a fresher to start working on this from where he needs to start. So I would again, as a fresher, which direction you want to do it, that depends. It if you want to become a Gen AI developer, basically whose sole job is actually to simply consume this model or basically understand this model and then work on it. Uh, you can simply learn about how to host this model. Olama is enough from this perspective. Learn about which model performs best in which class. Learn about agentic AI on those cases. If you want to be a data scientist, then hosting and at least fine tuning and all you should be knowing at least if you wants to go into Gen AI space. So again, which path you wants to follow, how depth in you wants to go, that describe it. See, if you understand a process of event training 1 billion parameter model, right? That is enough to have a cursory knowledge. So if you are able to train, let's say, train a model on your 32 GB machine locally for a 1 billion parameter on a quantized way itself, right? And you do a benchmark, you understand which is better, what is not. That is still would be enough. So I would suggest those things would help you get the right track. But again, think about a milestone, what you wants to become, GenAI developer or GenAI data scientist, and accordingly you set up a path. You can ask these questions to GPT to give you better results, or basically more structured approach to this. Perplexity.ai I always recommend. Use that. It gives you very good results in many cases actually, even the free version. How can we incorporate your own data into this model? You can do pre-training, fine-tuning, or knowledge distillation at all three level. You are able to pass your own data set as well. So what request and response what you add to this model, or what pre-training made, that's what we do basically. Let's say if you are into let's say finance domain, right? Or you are into healthcare domain, you want to train, you have a llama 70 billion model which has been trained generically on all things together in equal times, but mostly your data is mostly related to healthcare. So what you do, you simply put all these files into a text format or a PDF, basically mostly in text format in a bucket, and or if it is PDF, you runtime convert that into a text and pass this model to this model. That will allow you to pre-train. If you have a question and answer format, do it in a JSON format, and you can use that to train this model actually, fine tune this last layer model actually in this. So that way you can use your own data for those cases. Hope that answer your question, Afsal. Umar, maybe a session on data curation strategies and fine tuning. I'm not expert into the data engineering side. Maybe I'll ask somebody to pick that up. Maybe Umar, you itself can do that along with Ismail Bhai is one thing, person I know. So I think you guys can do that session. Yeah, or if not, I will ask work out basically which with Saif that who could be the right candidate to have that session. So data curation strategy for fine tuning SLM. Okay. Jazakallah khair, Naveed bhai. How to start, from where to start as a beginning for a full stack developer? I would suggest if you are a full stack developer, again, just one more thing and further to fine tune yourself is full stack developer looking for a job, and if that looking for a job in a top companies, go for a different route. But if you are looking for a job in startups, then there is a different route, right? Top companies is like what we call manga. If you're looking for Amazon and all, you have to be very good into this lead code and all these problem solving algorithms, knowing about time omega notation and all, which I'm also not expert of. But you build that line. But if you're looking for jobs in startups, how quickly you can basically learn a new tool and develop it, that's what it looks for. But again, every look for a T model, right? I think this has been a very popular term right now even in HR. Build You should have a breadth of knowledge across multiple streams, but you should have a very good depth at one subject. If you call yourself full stack developer but have a T or a depth in maybe in backend, maybe in Java, maybe in Rust, or any one language or any one tool, right? And then have a broader level knowledge in most of other things. And with GenAI, I didn't know Python at all. I didn't know data science at all last 1 year back, right? But all using GenAI, I'm able to generate, let's say, large project out of within 2 days. So even though not knowing syntax of Python, I'm able to write it just because I have a fundamental background knowledge of Java, right? Because that's what the background I came from. So I correlate everything to my Java knowledge and then I answer it. Similarly, build expertise and in-depth and one language, right? And then have a scale across others, and then that's how you should target. Hope that answer your question, Al Farid. Ayatul, minimal configuration required to start with downloading a model trying. No minimum, 1.5 billion model, even if an 8 GB machine, you should be able to run it very easily. So, uh, or it is not going to crash your machine. You download a larger model, it will simply say, I'm not going to run, or maybe hang you restart. That's it. Okay, download Llama and maybe you can do from there. Even if you don't have a GPU, it still work. Only thing it would be very slow. That's it. Okay. I have a lot of questions may not be feasible to ask here. If you can drop your contact or email, maybe I'll give you my LinkedIn profile. From there, I can give you personal email ID. From there, we can take it. So I'll paste that in the chat for others. Uh, okay. What was the other question which I missed? I'm from IT security background. Please share a good resource where can one learning AI. I would suggest, Nasir bhai, you should do a crash course of Gen AI so that you understand what is happening. And with security, there are a lot of things happening. Even same concepts what used to break the security in a network security, uh, like hijacking, the input hijacking, and all those things. Same thing happens with Gen AI as well. We call prompt hijacking, prompt, or basically I don't know the exact names, but it's like this. You design a agent, or you design a application using Gen AI, which is supposed to do one thing. Maybe it's customer support, but you ask it customer support, how many planets are there and all. Somebody can misuse it to get an answer where you get a cost. So it should only answer to your domain. And if somehow it is started answering other domain or thing which it should not supposed to do it, that's what it happens. There is a guardrail of goes with the Gen AI as well, that also somebody needs to understand. So that all those things comes part of it. I would suggest two things. Do a basic Gen AI courses. These are available everywhere, free, paid, and all. Do that. Second, ask Perplexity or maybe ChatGPT or Claude or any platform to what the top 10 material one should follow for Gen AI for security. That would give you enough idea about how you should think about security with the Gen AI applications. Uh, I think Jazakallah khair. I have, sorry, chat is going up and down lot. Is AI developer role after 18 years of experience? Is AI developer role after 18 plus year experience is recommended in today's IT? So, Ismail, bhai, it would be based on what role you are playing. I am playing role as a consultant, but I am doing day-to-day development, basic development at least. So having little bit of knowledge about the domain is still needed. But again, it depends on after 18 years what role you are right now into, or what role you are finally looking for yourself. Accordingly, you can think about whether would be useful or not. Okay. I think every time a new question comes, it refreshes the chat. So I'm not able to get all the questions. After I did an MBA in business analytics, please complete the internship as a business analyst looking for a job. Should I learn? Uh, I would suggest learn do a Akib, do a prompt engineering course at least, and because that is not an AI part, and now every job is actually doing it. See, I'll tell you this. Uh, I work with the education startups. I'm seeing startups are hiring MBA interns and even non-interns, non-MBA interns as well, and asking them to generate content just using these license tool. Maybe they'll use, let's say, Amazon products, Nova and all, Bedrock, and maybe Sora and all. So what they are doing, they're generating video from different sources, connecting them in Canva, and creating video every day, right? So you should have at least this level of knowledge, that maybe do a what is Gen AI for business person. That as a workshop, maybe it would take hardly 2 to 3 days. Understand that, make your own note, test it out, and do a prompt engineering course, right? And do certain small courses yourself. Every job is actually uh, either company are building their own AI tools, or they are buying these tools, which is basically enabling every job right now with AI. Okay, so I would suggest have that basic knowledge at least. I don't want you to go with what is SLM and all these things, but at least how to get work done through the Gen AI. Because most of the write-ups which people are writing, Happy Diwali messages and other messages, personalized messaging, all things are happening now through generative AI itself. Recording, we'll share it, I think, separately in the WhatsApp group, and as well as YouTube links has been updated, so it will be available there sometimes. Can you please shed more lights on tokenization in GPT model? Okay, So it's more of a technical concepts, but tokenization is basically, since computer does not understand text or basically English, everything for it is in English. It is a what I can say. It's a it's a number, right? It represented in 0 and 1. So one thing is, let's say hypothetically, I can create a full dictionary, right? And I say every word in the dictionary has one number. So I'll say starting with A is number 0. Maybe something zebra has a number, maybe 200. If there are 200 words in my dictionary, right? So I created whole this dictionary. That would also work, right? But think about this: if I give this as a number, since let's say there are more than 2 million words in an English dictionary, that would be very sparse metrics. Sparse means if a sentence represent a sentence, then all these words are not related much to each other, and there will be lot many zeros in between. So instead of that, what we do, we create a common words, or basically we call bag of words, and we assign related words a smaller value, sorry, similar value. Okay, and we create a vector. Vector is, as I shown you earlier, right? Vector is like multiple words. So for example, to represent one word, instead of I, let's say I say small, right? So small as a word, I will represent, is it part of size? I'm just giving a hypothetical number. Internally, there are vector embedding models itself who design that. But let's say small can be is a, let's say it's an adjective. So I'll give adjective score here. Second line would be maybe whether it is things to calculate. Yes, it could be small, medium, large. So that's another value. Is it a name? I'll give a zero value there, right? If it is a place, I will give something else value there. So maybe this way, this is some hypothetical example I'm giving just for the explanation. Similarly, you pick the next language. So language, it is it a noun? Yes, I'll give maybe more score on that. So everything, maybe it would be, so typical vector embeddings can have 128 or 1000 or even more than that number of value in a single vector. So each word is being represented in let's say 1000 floating point value. So maybe I'll give you example: vector embedding for, oh, here. This is one of the famous model actually. Uh, so it allows you to create a dimension up to 1024. So that means every word will being represented in 1024 vector value. You can say less as well if it is all together of a same domain. For a smaller application you can do that, but if you are doing more summarization and more this thing, you can go 1024 domain dimensions actually. This is embed English v3 model. Okay, 384 4096 is also there, right? That way you can do. Binary is also there. You simply do 0 and 0 1 to reduce the storage, but again, it reduce the accuracy. So a vector embedding is goes in that. Since a single word, tokenization, token, all these are part of the same word. What we do, and language breaks this into multiple small chunk of words. That is called token, and every token represent as a vector. So you think about this. So formula is like scalar can be scale hyphen r. So scale and r are two different words, so that I can represent scale and r. That way. So that's how it is being done. Hope that answer your question, Shakir. So vector is kind of the same word. Matrix can be maybe two words that way. So it again depends on the embedding model to think about how the tokenization are happening. Jazakallahu khair, Abu Samad bhai. Okay, good. Multilingual bird creates 768 dimensions. Thank you. Okay. Any last questions? Otherwise, we'll take a break. Okay. Jazakallah khair. Hope this session was useful. Uh, I think there are WhatsApp group there. Maybe if Saif bhai can add you to one of the group, uh, so that way you can do it. So from whichever sources you got this link, ask them to get yourself added to one of the MFIID group. We'll add you there. Jazakallah khair.